Welcome to Keys, Consumer Math and Personal Finance. This is section 1.5, the language of algebra. I'm going to read to you from your book for a little bit. It says, algebra is a generalization of arithmetic. It is a system for expressing a relationship between quantities using symbols, numbers, and operations. Some symbols, such as x, differ in value from one problem to another. Such symbols are called variables. James 1:17 tells us that there is no variableness with God. God never changes. He is the same yesterday, today, and forever. And that's also in Hebrews 13:8. However, variables change in algebra, and that's what we're going to look at today. In fact, we're going to look at not only the definition of a variable, but several definitions and properties today. Like I said, our first definition will be a variable. A variable is a symbol used to represent an unknown number. So basically, it's a letter that represents a number that we don't know, and it can change. You can use X, you can use N, you can use R, you can use any letter to represent a number that you don't know what it is. A constant, however, is a symbol that's represented by a fixed number. It's a number that we do know. 2, -5, 3.4 are all examples of constant numbers. They're numbers that don't change their value. An algebraic expression is a collection of variables and constants that you perform operations on. For example, 3ab is an algebraic expression. That is 3 times the variable a times the variable b. Or you've got x plus 4. That is an algebraic expression. It's a variable and a constant, and the operation between them is addition. So they're collected together with the operation of addition. And here's another one, 2x minus 5y. This is an algebraic expression with both products, 2 times x and 5 times y, and they're subtracted. So you've got multiple operations that are performed on that expression. A term can be a number, a variable, or the product of a number and variable, or the quotient of a number and variable. So up here, this first expression right here, 3ab, has one term because it's the product of three different factors, 3 times a times b. And then this expression here, x plus 4, has two terms. It has the term x, which is a variable, and the term 4, which is a constant. Terms are separated by pluses and minuses, or addition, the operation of addition, and the operation of subtraction. This expression here also has two terms. The first term is 2x, the second term is 5y, and they are separated with the subtraction sign, or the subtraction operation. Once again, terms can be numbers, variables, or the product or quotient of numbers and variables. Now, in terms, there are some special parts, and those parts are called the variable part and the coefficient part. So in this first term, 3ab, the variables are a and b, but the coefficient is the constant, or the number part. It's the number that's multiplied by the variables. In this expression, the first term, x, has a coefficient of 1 because 1 times x is x. So anytime you do not see a number in front of a variable, it's understood that the number is 1. Its coefficient is 1. Number 4 in this expression is a constant. It's a coefficient that is a constant. You can just call it a constant. And then in this expression here, 2x, the coefficient of 2x is 2, and the coefficient of 5y is actually -5. It's minus 5y or plus a -5y. So the coefficient of y is -5, the coefficient of x is 2. Like terms are two or more algebraic terms that have the same variable with the same exponent. So in this expression here, 3x plus 4y plus 2x plus 6y squared, I've got some like terms that I can collect. The first set of like terms would be 3x and there is another term just like it that has the same variable with the same corresponding exponent, and that would be 2x. So I could collect those two together and add them, because I've got 3 x's and I've got 2 more x's, so when I simplify that, I end up having a total of 5 x's. They're the same, so I can add them together. Now let's look at the 4y and the 6y squared. Those at first may think, okay, those are like terms, but they're not. You do have the same variable y, but this second one has an exponent of 2, whereas this first one has an understood exponent of 1. The exponents for those variables are not the same, so they are not like terms. So this simplified expression would be 5x plus 4y plus 6y squared. Green gives us another example to compare like terms. So let's look at 2x. Does it have anything else in this green expression that matches it? Same variable with the same exponents. No, it doesn't, so we're just going to leave it as 2x. Now let's look at the 3xy. I've got 3x and y. Is there any other xy term with just xy? Oh, here's one. Negative xy or negative 1xy. So 3xy minus 1xy is 2xy. Well, let's see if there's anything else. Ooh, there's an x squared y term, but that is not the same. It's not a like term because x is squared here and it's not in the other ones. And that's not the same either. So 3xy plus a negative 1xy or minus xy is going to end up being positive 2xy. I do my rules for addition. Signs are different, so I subtract, take the sign of the larger. And then I finish with that one and that one. So now let's look at 4y. Are there any like terms with that one? We've got a 4y over here. Oh, I have a 4y here, a negative 4y. The coefficients are different, but the variables are the same because this 4 is a positive 4 and this is negative 4, so that's why the coefficients are different. But the variables are the same, so that makes them like terms, so I can collect them, and 4y minus 4y is nothing, so they become 0. They cancel each other out, and I'm simply left with the x squared y, which does not have any other terms like it. So that green expression simplifies to this red one when I collect the like terms. For practice collecting like terms, then look at example 1 on page 19. The last two definitions I want to go over before we move on to the algebraic properties are the definitions of an equation and the definition of a formula. An equation is just a mathematical sentence that equates two quantities, or you put an equal sign between two different quantities and you call it an equation. For example, 2x plus 1 equals 3 is an example of an equation. Or you could even have 2x plus 1 equals 3x minus 4. That is another example of an equation. It's two quantities that are set equal to each other by using an equal sign. And the last definition is of a formula. Now, a formula is a special kind of equation. It is an equation that relates at least two variables. So, for example, you can have the formula for the perimeter of a rectangle. P for perimeter equals 2 lengths plus 2 widths, and that would help you find the perimeter, that formula. Or you could have the distance formula. Distance equals rate times time. You use a formula the same way as you would evaluate an algebraic expression. You replace the known variables with their values, with their known values, and then you simplify or solve for the unknown variables. We are going to do examples of this on the next video, part B of 1.5, after we talk about mathematical properties.